Hi students. So today we will discuss about the capacitors and capacitance. See, it is the part of electric potential. So we have already done two videos on electric potential part 1 and electric potential part 2. So you can take it as the electric potential part 3 also, but we will take it another heading, that is capacitors and capacitance. First of all, we have to learn what is it. What is a capacitor? What is the use of it? Okay, see, capacitor is basically, we can say, it is an electrical circuit elements. Whenever we have learned earlier in class 10 about resistance, so that time we know that like resistance, capacitor also one kind of electrical equipment. What is the use of it? Okay, then I will come how it can be formed. What is the use of it first? See, when we are talking about an electrical instrument like fan, motor, kitchen chimney, in this type of instrument, to start this instrument, we need a huge amount of current to start the instrument. Okay, so how much amount of current is needed to start the instrument? Generally, to work continuously, it needs very less, around very less, you can say around 2 ampere to 3 ampere. But to start, it takes around 25 to around 45 to 50 ampere current. And now the question has come, how we can able to supply that much amount of current, by which method? So for that case, we need an instrument which is known as capacitor. Capacitor is an instrument which is used as a charge storer. So it is an instrument which stores charge, and when you need it, just distribute or give the charge to the instrument suddenly, and then this instrument starts. We know whenever an instrument, whatever the instrument may be, when it is stopped, there is a property that is known inertia of rest. We have learned it in class 9 plus 11 also, inertia of rest. So when any instrument is at rest, so it will have an inertia of rest. So when we apply a energy to move it, so we have to overcome this inertia of rest. So that means we have to apply more. As well as when it is static, so to overcome the static friction also, we need to apply much amount of energy. After that, whenever once it gets start, then it will go on. Okay, once it gets start, it will go on. But to start, huge amount of current is needed, and for that reason one instrument is used that is known as capacitor, and which is used as a charge storer. So charge, here charge means we can say the energy. Okay, it stores some energy, and whenever you switch it on, then this energy is being distributed. Okay, distributed to whom? Distributed to whatever the instrument it is used. Okay, so that is, you can say, the preliminary idea of a capacitor. Okay, now the question has come, how we can able to make this. If I am going by the definition, just capacitor, it is basically two conductors are kept closer together. Two conductors are kept closer together, then only a capacitor is formed. Assume it is one conductor. and it is another conductor. Okay, see, we have kept it very much closer together, and now if we connect it with a cell, see, there is no connection between them. So which one is connected with the positive terminal, there the positive charges will store. Similarly, where the negative terminal is connected, there same amount of negative charges will store. Okay, so what it can be asked by you, sir, why it should be same, why it is not different? Because simply whatever the positive charges will come due to the induction, same amount of negative charges will also come here, and by this way we can able to store the electric charges, and that is an instrument by which we can able to store some amount of electric charges. That is our capacitor. I think the idea of capacitor, it is very much clear enough. Okay, now we'll go for equations. See, before going to the equation, I'll just make you remember one thing. See, in electric fan, most of you have seen one cylindrical things are given like this one, two wires are coming by this way, which is told that it is a condenser. Many a time, mainly in summer season, the fans, when it is work for a long time, then sometime happens that the speed of the fan is decreased, and the mechanic come and tells us that we have to change the condenser. What is this condenser? This condenser is nothing but the capacitor. It is used as a charge storer. How do you understand it? See, these two terminals are coming outside now. Just make touch whenever which condenser is west. Just take it from the mechanic and just touch these two where you see the flushing. Flushing means there must be two charges are here, and when you charge they are dissolving. Okay, and that's why this charge, this flash you can able to see. So this is the use of capacitor. Now we are coming to the next part. What we can able to find from capacitor? Let's see. Now the question has come, sir, you are talking about capacitor, you have told the use about capacitor, but problem is that how we can able to form it and what is the equation? Because see, any electrical instrument which what we are going to use, we need a certain equation, certain property, otherwise we cannot able to use it later. Okay, so if I'm talking about a conductor, as an arbitrary conductor, okay, some amount of charge is here, assume the charge is q, okay, and due to the charge there will be a potential is created here. We have just learned for a point charge, if it is a point charge q, then at r distance potential equals to q by 4 pi epsilon naught r, where epsilon naught is permittivity, okay, in free space. And here also, due to the charge q, capital Q is distributed over the conductor, that's why there must be a potential created. Okay, now in this potential, if you want to take another charge to put, see, Q is there, due to Q there is a potential on this plate. Now assume you have taken a small charge dq and you just want to take and put it in that conductor, means you just want to increase the charge of the conductor by small amount of charges adding where, through the conductor. Okay, we know one thing, more the charge from this equation, more the potential at a certain distance. If I am taking distance is constant, then more the charge you have taken here, more potential is created. Okay, and more potential means more repulsion to the charge is coming. More potential means you need to do much amount of work to give that small amount of charge here in this conductor. Initially, whenever you have taken the small charge dq to put it here, how much work you have done. Next dq charge whenever you have taken, then your amount of work done should be increased. Okay, so we can say that potential is directly proportional to V. Potential is directly proportional to V. More the charge, more the potential. Okay, and here see, if I am taking another conductor, if I have taken another conductor, the distribution of charge is different, and there the potential may be different. So for different conductor, this idea of potential that will be changed, and for that reason we have to take a constant here, and that constant is known as capacitance. Capacitance is what? It is the inert property of a capacitor which depends. One thing you have to learn from here, very important thing. It depends on the dimension, that means the size and shape of the conductor, as well as the medium. In which medium you have done the experiment, there also. On that thing, this capacitance depends. What is capacitance? See, just now we have told now that capacitor is used to store the electric charges. So for different material, this storing property is different. Now, if it is different for different material, then how we can able to store charge? So for that reason, we need a certain property of the material by which we can able to understand which material can able to store which amount of charges, what should be the size of the material, what should be the medium of the material, and that is denoted by capacitance. C is equals to Q by V. Now you may ask, sir, if I get charge and get potential, by dividing it, we can able to get the capacitance. It is very easy. Then why we are talking about dimensions and medium? If I know the charge of a conductor, if I know the potential, then by that we can able to find the capacitance. See, now I'm coming to the point that charge and potential, by taking the ratio we can get the capacitance, but to tell the truth, capacitance doesn't depend on them. Now you have to ask, how, sir? Simply we can able to calculate the capacitance by this, but why it is not depending on capacitor? I'll make you remember one more equation. I think you can able to remember this equation. You know, here R is the resistance, right? So resistance of a conductor can be calculated by taking a ratio of potential difference and current by Ohm's law. But when we are talking about on which thing the resistance depends, for that we have defined one more equation. R equals to rho L by A, where rho is resistivity, L is the length of the conductor, and A, that is the cross section. That means in short, it comes on the dimension of the conductor. We can able to calculate the resistance by potential and current, but it depends on the dimension of the conductor. Similarly, we can find the capacitance by taking a ratio of charge and potential, but it depends on the dimensions of the conductor as well as the medium where the capacitor is kept. Okay, now I'll make you more clear with it. As we have got capacitance, so here I can able to find the SI unit of it. What is the SI unit of capacitance? So from this equation we say that capacitance equals to Q by V, charge by potential. So SI unit will be Coulomb by volt. That means Coulomb volt inverse. and that is denoted by another unit which is known as farad. F-A-R-A-D, farad, which is denoted by capital F. That is the unit of capacitance. That is the unit of capacitance. Now the question, I've given you a very interesting idea, you see. If it is told that one capacitor's capacitance is 1 farad, what do we understand by that? If it is told that capacitance of a conductor is 1 farad, what the things we can able to understand by that? Listen to me very carefully. 1 farad capacitance means if you take 1 coulomb charge, your potential will be increased by 1 volt. If you take 1 coulomb charge to the conductor, then its potential will be increased by 1 volt. An interesting thing is, as the potential is increased, definitely it will not allow any more charge to come. That means to take another charge, you have to do more work. If I have taken 2 farad, so we can write it down 2 coulomb by 1 volt. So by getting 2 coulomb charge, the potential is increased by 1 volt. Previously for 1 coulomb charge it is increased by 1 volt. And now for 2 coulomb charge it is increased by 1 volt. That means for the next one, for 2 farad, the charge capacity is more. The charge capacity is more than the previous one. The first one, by 1 coulomb, 1 volt potential is increased. But second one, by 2 coulomb, 1 volt potential is increased. So more the capacitance, more the capacity of taking charge on it. More the capacitance, more the capacity of charge just taking in it. That is the idea of capacitor. So see the thing. If you want, write it down also. This is a very important part of class 12. Capacitors and capacitance. Okay. Now, we'll go to the next part. The next part is, see, before starting the next part, I am clearing you out. It is not needed for your exam. In exam point of view, it is not much important, but it is important to learn the word capacitor more. So if you want to learn it, then you have to see. Otherwise, if you want that, it will not come in exam, so we will not focus on it, then you can go. But I think you should see this. The next part we are going to discuss that for a sphere, for a conducting sphere, what will be the capacitance? For a conducting sphere, what will be the capacitance? That is our target. So let's see. Conducting sphere. Okay. So capacitance of a conducting sphere. So assume you are having a sphere of radius r. Okay, total charge is distributed on it. We know no charge can able to stay inside the conductor. Always the charge will be staying outside or at the surface of the conductor. Okay, that we know. Okay, 1 minute. Sorry. So it will stay outside the conductor. Now the question has come, what should be the potential at a certain distance? Assume we have taken at a certain distance smaller. Due to the charge distribution, Okay, if the total charge is q, that how much potential at a certain distance small r. And here we can say that total potential at a distance of r. So here for the case of sphere we can assume it as a point charge, we all know that, and where the charge should be stored at its center, that we have learned whenever we have find out the electric field also. We have assumed the total charge is at center, so all the distance should be counting from there. So potential V equals to 1 by 4 pi epsilon naught small r into q. Okay, or we can say q by 4 pi epsilon naught small r. So simple, whatever we have done for a point charge, that should be same for a spherical distribution of charge. Okay, so V we have got. We know the total charge is q. So if total charge is q and V we have got, we can able to find C, because we have just known C equals to q by V. So put all the values. So q by, instead of V we can write q by 4 pi epsilon naught r. See, q will be cancel out, 4 pi epsilon naught r. So that should be a capacitance of a spherically charged distribution on a conductor. C equals to 4 pi epsilon naught r. So if you increase r, it should be increased. Now if I want to ask what will be potential at the surface, so at surface, as the charge has been stored on the surface, so capacitance C equals to 4 pi epsilon naught capital R, because capital R is the radius. So this is your capacitance. Now we can able to find out also one thing, that what should be the charge storing capacity. So what will be the we can say the radius if the capacitor is its capacitance is 1 farad. So we can find out if C equals to 1 farad, how much radius will be there of the sphere. Okay, let's see. So C equals to 1. So from here we can say C equals to 4 pi epsilon naught R. So R equals to C by 4 pi epsilon naught. C is 1 and 4 pi epsilon means 1 by 9 into 10 to the power 9. So answer is 9 into 10 to the power 9 meter. So to get a capacitance of 1 farad for a sphere, the radius should be 9 into 10 to the power 9 meter. Can you imagine how much large it is? If I am talking about the radius of the earth, the radius of the earth is also 6.4 into 10 to the power 6 meter. So to make a charge capacity 1 microfarad, you need a sphere whose size is more than the size of earth. So this is one of the big cause that there we cannot use a conductor of spherical shape as a capacitor. We are talking about a sphere where the charge is distributed. That type of capacitor we cannot use as a charge storer, because we cannot able to store charge. See, to store means if I am taking 1 coulomb of charge, it is increased by 1 volt. For that only we need a sphere of size 9 into 10 to the power 9. So how large it is, we can imagine from that. Okay, this is one of the important cause, that reason that we have taken a capacitor which is having parallel plate, and that one is very much important for your syllabus. Parallel plate capacitor, parallel plate capacitor. So before going to the parallel plate capacitor, here we have to learn what is the drawbacks or limitation of the spherical charge distributing capacitor. Here, number one thing we have seen that capacitance is low, very low, because for 1 microfarad if you need 9 into 10 to the power 9 meter, that is huge. Okay, so generally we cannot able to use it. And number two, energy loss is more. Why energy loss is more? See, the charge is distributed over the surface. So here, as the charge is distributed over the surface, so it can able to induce the nearer air molecules. We have learned about the lightning conductor and how the lightning conductor works. In lightning conductor, we have learned in class 8 only the lightning conductor which is kept at our roof, because the point surfaces the charges are more, and these charges will induce the charges of the cloud and they will come closer together, and due to this discharging, what will happen? Due to that discharging, the capacity of charge in cloud, it will be decreased. Okay, here also, as it is connected to the whole air molecule, so the air molecule should be polarized. As there is positive charge, so in air molecules the negative charges will come. Okay, and here the positive charges will store, and here what will happen? Discharging will occur. Okay, this one is known as corona discharging. Very interesting thing. Now we are in a situation of coronavirus. Okay, and this one is known as corona discharging. So that is a bit higher class thing. So you will not needed to learn. But one video I think you have seen in many films, in many cartoons. You have seen this kind of video that there is a globe-like substance. Okay, and there is some discharging is occurred from here. One who is putting hand on it and the discharging is occurred. This type of discharging is known as corona discharging. Okay, so it means why it is known as corona discharging, because if you have seen nowadays, it is very common that whenever you have get on the TV, you can see the diagram of the coronavirus. So it is seems to be a spherical thing where some this type of crown type of things are there, and by which the corona name has come. Okay, and when there is a charge, this type of sphere, so huge charge, assume there is huge charge is kept, and due to this charge, the another air molecules which are exactly side of it, they are get polarized by it, because as there is a positive charge, so they will attract the negative charge here. Here also they will attract the negative charge. So when this positive and negative come closer together, we know the flashes will come. Okay, and that is called corona discharging. And by this way, the total charge of the sphere, it will be decreased. That means continuously, if I am just storing some amount of charge in this sphere, you will see after some time the net charge is less, because some amount of charge is being discharged in a form of corona discharging. This is not acceptable. We want to store the charge. If the charge is lost, so what is the use to of this type of sphere? Okay, so these are the two reasons where we cannot able to use a sphere as a charge storer. What we have used? We have used parallel plate capacitor. Now we have to learn this thing. Let's see. What is it? I think now you can understand what is capacitor. It is same like resistance. Okay, later you will come to know another electrical elements, circuit elements in magnetism whenever we will go. Okay, but before that we have to learn this one, parallel plate capacitor. What is parallel plate capacitor? I have just drawn a diagram earlier that if two parallel plates, conducting plates definitely, if it is kept like this at a certain distance from each other, two plates having a gap between them, let's the gap is d. Okay, it is told the gap should be much smaller than the dimension of the plates you have taken. Okay, so that comparative means if I compare the total area with the diameter with the distance, then it should be infinity. Okay, whenever someone will come here, you will see that it seems to be infinity. Just like assume if you gone to a big city, we know there are much lesser place. So there are two buildings. Okay, two buildings are very much closer together. Whenever you have gone by that path, you will see the two buildings seems to be infinity comparative to you. So here also the same thing is just want to express. So two plates is kept and it is connected with a cell. Okay, so where there is positive, there should be the positive charge. Where there is negative terminal is connected, there is negative charge. In one plate, the positive charges will come. Okay, and in another plate, the negative charges will come. See, what will be the capacitance, that will have to come little later. But here, as the two charges are very much closer together due to the induction, so here the loss of energy is been less because no other charge is here at back, it is connected. So here it is not possible to discharge from here because these two charges are here and there will be an electric field. We have learned the electric field is acting from positive to negative, and due to the strong electric field the charges cannot able to escape. These charges cannot able to escape. So as they cannot able to escape, the problems we have seen for spherical charge or for spherical distribution of charge, that can be solved. Okay, that can be solved by this way. And now the thing we have to learn here, that what should be the capacitance of a parallel plate capacitor. What will be the capacitance of a parallel plate capacitor? So here we have to assume something. Let area of plate is equals to A, distance is equals to D, charge is equals to Q. So Q means here it is positive Q, here it is negative Q. Okay, but the total charge it remain constant. If I am telling what should be the charge density, that is equals to Q by A, and we know Q by A is denoted by sigma. Q by A, it is denoted by sigma. Now assume if I have assumed a smaller portion here, okay, a very smaller portion. Okay, so here it is D. So if I remove the D also, if I have written D here, so it is a smaller cylindrical portion. This portion, this type of surface is known as pillbox. Okay, initially the pillbox have come in this cylindrical box. Not only that, in initial days the cigarettes or this type of smoking elements are also coming this pillbox. Nowadays also many more things. If you go a pawn shop, there you will see that is kept in a pillbox. So that type of pillbox we have assumed. So here the area of the pillbox is delta A. So total charge in the assumed surface is equals to sigma into del A. Charge density is sigma, so total charge in delta A, that is sigma into del A. Okay, so from here we can able to find out the flux phi E. So flux phi equals to integration of E dot ds as per Gauss's law, and that should be equals to Q inside by Q enclosed by epsilon naught, that we know, right? And here E dot ds equals to Q inside or enclosed here. So what should be the angle between them? E dot ds. So we know the direction of E. The direction of E is acting in this direction. If you see the direction of A, okay, please try to see it. The direction of E and the direction of A both are in same direction. So we can directly write down that E dot ds equals to integration of E ds cos 0 degree, that is equals to Q inside by epsilon naught. E dot ds cos 0, that is 1, E, it will be coming outside, ds, that is 1 delta A, and Q enclosed is sigma into delta A by epsilon naught. Delta A will be cancelled out, E will be sigma epsilon naught. So we have find out the electric field. We have find out the electric field of the plate. Okay, we have find out the electric field of the plate. Now we have to find the potential. Now you have to ask the question, sir, why we are doing this type of thing? Why we need to find potential? See, we have to find the capacitance, right? Okay, so capacitance C equals to what? C equals to Q by V. Capacitance C equals to Q by V. So if I know the total charge is Q, you have to find the V. If I get V, then it is very easier to do. Okay, so now we have to find V. We have just know that there is the equation that E equals to minus of dV by dr. We have just derived in the previous class that E equals to minus dV by dr. So from here dV equals to minus of E dot dr. Okay, E dot dr. Now the question has come, what will be the value of E? The value of E is sigma by epsilon naught. Now we have to find V. So V equals to, I have to write here, okay, V equals to integration of minus E dot dr. Now what should be the limit? Here, to understand the limit, please see carefully. If I have taken a small charge dq and I want to put it here, okay, I want to take a charge dq to put it here in positive plate, then I have to do some work. As you have taken dq charge from here, so here the net charge will be minus dq, and here if you add plus dq, so it will be added. Now you have asked, sir, what the things you are telling, we cannot understand anything. Whenever the charge is being created here, we are assuming that one by one charge it is being thrown here and it is catched all the charge, and by that the total positive charge has come, and here one by one the charge is less, that's why it is negative. We are assuming. Okay, so as it is coming from here, it is coming from D to 0 because the distance, you see how much distance is there, D distance. So we have to find the limit V equals to integration of D to 0 sigma by epsilon into dr. Simple thing, sigma by epsilon, minus sign is there, so sigma by epsilon, it should be 0 minus D, and minus is already here, sigma D by epsilon. So we get V. Okay, if we get V, put it here, C equals to Q by, instead of V it is sigma D by epsilon. Sigma equals to what? We have just learned Q by A. So it is Q by A epsilon into D. So Q will be cut epsilon A by D. that is the capacitance of parallel plate capacitor. This is the capacitance of parallel plate capacitor. See the interesting thing, it is also not depending on charge or potential, it depends on area and distance. Okay, area and distance. Okay, I think it is clear enough to show you. This is the way to find the capacitance of any substance. Okay, first you find the potential and then just take a ratio from the charge and you will get the total capacitance of the substance. Okay, as I have already told, it depends on the dimension. You see, A and D is the dimension, and epsilon, it tells us the medium. If you change the medium, the capacitance will be changed. So instead of air, whatever the medium you have taken, there the capacitance should be increased, because epsilon naught is the lowest one. If you have taken another substance, another material in between these two plates, then it is increased. Okay, I think it is clear enough. So that is up to the part 1. In part 2 many more things are left, so just try to understand the part 1 portion. Many numericals we can do, but see, for numericals I'll make another video. Okay, theory you have to understand, just what is the concept of the capacitor, just try to understand. Thank you.